Swayam Prabha. Digital India. Educated India.
Welcome, dear students. So, in our journey of learning bulk material transportation and handling system, we have been discussing about the mineral processing plant and equipment. Under this, we have introduced you different type of machines used over there, and also we talked yesterday about the type of maintenance systems you do it over there. Now, few more processing operations are there in a mineral beneficiation plant. Out of that, there is a one important area is concentration and separation. Now, as you know already, in the bulk material handling or bulk material processing, particularly when we are talking about extraction of ore, that is your metal from ore, in a metallurgical plant, particularly in the extractive metallurgy, there are some of the handling operations and processes where there is a different type of equipments are used. I thought it will be good for you that to know about the overall dimensions of this material handling business. Briefly, I will be telling you some of the concentration and separation work, which after attending this lecture, I hope you will be able to describe the various concentration and separation processes and discuss the functions of various equipment and devices used for concentration and separation, so that you can take some analytic job or an investigation about the performance and maintenance of such type of machinery and processes. So, what is exactly the concentration and separation? You know that we have talked about the primary, secondary and tertiary crushing, and then we said that exactly how you do the grinding in a ball mill or in a rod mill, and then also you do it in autogenous mill. When you grind, it becomes powder, and from there exactly we separate the gangue material from the ore valuable minerals. Say for example, in gold processing, when you have done this in autogenous mill, from that the gold particles will have to be separated with the associated rock or the waste materials. Now, while separating this very fines, it will not go as that screening which we were talking about, screening at the early stage of beneficiation. Now, we need to do it, but thing is that there we whatever the things we want to collect from there after the grinding, the concentration of the percentage of the valuable mineral will have to be increased. Now, that is what it is that process by which you separate out that gangue material, and then you improve this concentrator, that machine where it is done, that machine is called the concentrator. Now, this concentration job, it will yield two things. One is the concentrate, which will be used as your valuable, where from you will be extracting the main metal, maybe your gold or a nickel or this say your platinum, everywhere this will have to be from the concentrate only you will be taking. You may be hearing in the news and all that India imports a lot of copper concentrate, that is those concentrate which are in a processing place, they do it, say you are getting in from the Oak Teddy copper mines, India imports those concentrate, and this concentrate is ready for other metallurgical extractive metallurgy for extracting the metal. Other things also, you may be hearing one word, that tailing and tailing dams, that some of the, while you are separating these fines, those final reject which is going to the tailings, but that does not mean that tailings do not have the valuable mineral. There are. Now, sometimes this concentration and separation are also today will be coming with that, at that time, say at 20 years ago, 50 years ago, that whatever has gone to the tailings, because at that time the technology for concentrating and separating were not that advanced, it may so happen that whatever is lying over there can be separated out by this method. That is why I tell that why this subject is interesting for you, because when your no new mines are coming over there, but you may find that in some of the tailing dams there may be more valuable minerals which can be extracted from them, or it can be, if we can concentrate and separate over there. So, there comes the business. Also, you may be knowing that in a coal washery, that the coal fines which cannot be recovered, they are separated, that have gone to the tailing dams, but these are all carbon, there is a lot of calorific value is lying over there. So, that is how it will have to be utilized. Those things comes under handling of those materials which are lying in the tailing dams, and also the in the valuable you want to do from the mine run of mines you will be doing. So, I think now you know that what is the concentration and separation business. Now, basically the how to achieve this concentration, that means your the run of mine, when it is coming, you are crushing and then you are reducing, that is your ore minerals to a very particular size has been reduction, size reduction has been done. Now, you are having those fines, from there to develop the concentrate, you will have to look into what are the physical and physicochemical properties of that mineral. So, to select that in which way you will handle it, it will be depending on what are the properties that can be used for this, and depending on the properties used, you will be developing this different type of equipment which will do the job for you, because anything you will have to do, think in your mind, it will have to be designed, and there the engineering required, that how you will put the things over there. Now, that is exactly your separation and concretions, that job, that is, and the formation of the particle of individual mineral which will be using these properties. Now, what could be those properties? It can be color and luster, by there would be the ore picking. It is sometimes done manually in the past, say for example, the near in Barbil area or in Jharkhand, West Singhbhum district, there are many tribal ladies who are sitting down on the roadside on a piles of manganese ore, they are just picking up which is manganese and which is not there. By seeing the color, by seeing the weight of that by hand, these village ladies, they can do this hand sorting over there. Today, that thing has been done with the advancement of your imaging technique and advancement of your online weighing technique, advancement of the how X-ray and that your XRF can be done on the, while the material is slowly moving on the conveyor belt, they can be scanned, and then they can be, you can use, you can make them in a monolayer to go, and in between you can have an arm to push them, and then sorting out only the valuable minerals will go. That type of systems are coming, and some of the things maybe you may also decide, but only thing what we will have to know, that whatever was done earlier by visual eye and then by observing and then by their experiences, that is now with technology you are getting a, that is your by ICT applications in this ore sorting, that handling is done. Then other thing is there, natural and induced radioactivity. Sometimes some of the radioactive minerals and all, you can have the radioactive detector by which you can separate them out. If you are separating, you are improving the concentration, that is the philosophy. Then the most widely used system is the density differences. This is a very, very important thing. You know, all atomic, that is all the elements, depending on their atomic number and mass number, how exactly their total molecules weight, and that your particles weight will be varying, density will be varying. That means every mineral, everything has got its S signature, that is density. Now, if you can use that density differences of the valuable mineral and the gangue mineral, so if you have got a system which can take that the heavier things will be settling down, lighter things will be going out. When the lighter thing is going out, you separate that out. That is how exactly the your concentrations can be achieved. Now, then another thing is there, if you are putting them to move in water, that is your materials you are keeping over there, they are flowing around things, and then along with the water, then in that water, that the particles will be having different velocity, settling velocity will be different depending on the size of the particle and depending on the weight on the particle. So, that can be used, that how they exactly settle in the water, that can be also a property by which you can separate it out. Then there are some, that is the electrical property may be changing. With the electrical property also there could be a machine. Then thermal properties, some under heated conditions they will be your target mineral may be behaving differently, your non target mineral will be behaving differently. Identify the behavior and separate it out. That is the thing. Then size, shape, brittleness, coefficient of friction, these are also some of the things you can separate it out. It is just like the particles will have to be separate. It is not like that, that is in a class you can say all the tall students should go sit at the back and short students come in the front. In our primary schools you have seen how our teacher used to sort in the class, that then they will be separating out the students so that they can get the learning better. This is something same way that particles will have to be separated, so that the same type of things put together means their concentration is increased. So, this can be done by various methods, that what exactly you will have to learn scientifically and then you will have to execute as an engineer's way. Now, this could be done by some of the words you will be learning in this class is your zigging, then there is a dense media washing, there is a concentration by tabling, that is a tabling, then concentration by sluices. I will not be discussing here the sluices, you may get that all the alluvial mining you might be hearing in the river Subarnarekha or the Swansiri, or in those rivers in Arunachal, they used to get this sand washing for getting the gold, that how they were separating those things, and then how the hand penning were done in the river Subarnarekha. Those things were also a concentrations. There they used to have a sluice. Those exactly in the alluvium mining, still it is used in some places in Alaska or in some of the in the Pacific, South Pacific ocean islands, where this gold are there, they do it like that. But the other thing is the flotation or the magnetic separation. These are the different methods. So, by now at least if you have noted down while you are listening to me, make a practice of writing it down, then what are the properties and what are these different methods. Take an exercise, write down these properties name and write down these methods, match it which one is there. On at least by doing this simple exercise, you will be enhancing your level of knowledge over there. So, the gravity and flotation methods are used most frequently in many of the things, and you will be learning. If those who are in mining or mineral engineering, you will be doing that more. Now, trends in development of this mineral concentration, this trends of development I will not discuss much over here, but what is there, they have been doing a lot of improvement in the individual concentration processes, and there is a combined processes. Now, whether that is how you will be improving the quality. So, as I said that in the 20 or 25 years ago, in the tailings lot of valuables were going out. Now, they are improving these processes by which that the recovery is increasing, that is your yield is increasing, that is what is the trend, and that is your how you can do it by intensification of the processes and the increase the equipment capacity. Their intensification means more energy can be given over there and they will do the work. So, there is a trend of development in that line. Then integrated use of minerals, that is your sometimes those tailings, even if it is whatever it is going, you do not bother about it, because from there also you are using something. That trend is your waste to wealth, whatever has been left as a waste mineral. Say for example, after iron ore beneficiation in any mine, iron ore mine, the beneficiations they will be taking only up to say 62 or 65% hematite. Rest of the things which are going in the tailings, there is always 30 to 50% of the iron is there. Now, there's some of them are being used for briquetting, some of them are used for some road making material and other, but now that exactly your how you can integrate their use is an important thing. Then another trend is today automation has come. Now, another thing is there, the latest trend in last 5-10 years is your data analytics. That means you are getting your data driven decision making in this. It has got a very good the deployment, and then almost all the mineral beneficiation plants and material handling, they want to optimize their system, and the optimization is identification of the effective variable and assigning their value, and there is a scope of a lot of your tools utilizations and things are there. So, this is just only for getting your interest into this area so that you can work. But in the field, if you go to any mineral beneficiation area, you may be hearing these words, that is your zig separator, that even in some of the coal washeries, if you go to Radarappa, in Radarappa coal washery, there is a, you may find a bound zig there, the jigging operation is there very much. Then shaker table, if you go to in the metal mining sector, in there are a number of places you will find this shaker table. The gold concentrator, in your old gold mines they use this gold concentrator. Spiral separator you can find in many of the coal washing also for removing this your dirty materials, that separator, the spiral separators are used. Magnetic separator you use in, say it was used in Kudremukh iron ore mines, where they were having those the beneficiation of the magnetite ore, which has got this magnetic property. Magnetite was separated like this. Electrostatic separator, of course you find it in your the dust separation system and dust collection system. Handling the dust is also by electrostatic separator. Flotations, you may be hearing about that, I think you have read in your intermediate science, that how steel is made. You know that this iron ore is beneficiated by froth flotation process. That froth flotation word is known by each and every engineer, because they need to know about the materials. No engineer can be an engineer without the knowledge of materials like steel, and that steel making where you need your iron ore, and that iron ore beneficiations still we will be finding a lot of that froth flotation process and all. There are in gold mine, in copper mine, in many where you will be finding out this froth flotation as a process. Now, coming to this, let us talk about what is this zigging means. A zig is a device that drives pulses of water upward and through a thick bed, and then with that they will be making the things to separate it out. What happens? The denser material will be coming at the bottom and the lighter material will be going up. So, that is in a coal jig, at a bound jig, basically they are getting these things. When the water is putting over here and you are giving a pulse of water like that, then your heavier materials are going at the down, because in a, you know, the coal density is 0.9 to 1.1, but the sandstone or shale whatever comes along with coal, their density is 2.2 to 2.7, 2.4 like that. So, what happens, sometimes in the shale, carbonaceous shale, sometimes they are 1.7, 2.0 like that density. So, some of them will be falling over here, and that when this whole particle will be moving in these directions, then your coal will be at the top, and from there you can have a launder through which this at a line, that is your coal is coming out. So, whatever the material you are getting it back there, they will be having that high calorific value per ton. But if all these were mixed together and 1 ton coal of if you burn, you will be finding only very less calorific value, and you know that you have got a different grade of coal depending on that. In sometimes when we get a 41% ash content coal like in your Mahanadi coal field, that coal if it is washed like that, it will be coming, and at 41% ash, it may be you are selling it say hardly your 1700 to 2000 rupees. But if you reduce this ash to say for example up to your 15-20%, bringing it to a high calorific value coal, in that it will be selling as a 4000 to 5000 per ton. Now, for whole process of washing, you can just by spending some money, you can increase your profit much more, and that is why this coal washing business came up. And whenever the business come, there is other business matter also comes in. There are a lot of issues related to this coal washing, you may read the newspapers. Now, this what is happening here, the jigging is also done in here say in case of gold mines, there also the what happens, there the heavier materials are collected. In that coal what was there, the heavier material was the residue. Now, in sometimes this jigging is done, so that particularly in the gold mines the gold processing, your gold and that other sandstone gold's density is more. That is why when they will be giving this whole water, the feed gold and ore mixed things after the your ball mill, after the autogenous mill, it is coming over here, and then you are giving some water into this, and then you are giving a pulsating things, so that there is a screen over here through which the gold particles are getting deposited over here as a concentrate, and then your this gang materials will be going out and they take it out. So, this is the way how jigging is done. Now, the next thing is your that hydraulic washing. Now, what is done there also the same principle, your gravity separation, that is when you are having this your water and that the mixture they are coming over there, then you will find that they in this table your the crushed ore is placed over here, the heavier material is going down and they are arrested by this corrugated boards, and that lighter particles will be going and they will be collecting over here. So, this is a hydraulic washing, you are just washing the things and getting the valuable collected over here. Now, there are different type of that concentration processes like your magnetic separation. If your the material which you have got from the mines after crushings, it has got the magnetic property, just like I told you a magnetite. Then what it may there, then you are having an electromagnet inside this pulley. So, as I told you in the magnetic separation, your powdered ore which has got your magnetic property like magnetite, which is attracted by magnets, then there is a non-magnetic and magnetic material, it will be allowed to pass through a slow moving conveyor belt, and that conveyor belt and pulley, inside that pulley are we are having those electromagnets. That is why they will be connecting over here, and then when it is coming into this position, that electromagnetic effect is not there. This will be again your electromagnet, this will be because your magnetic field is there in 1/4. After that it is again non magnet. So, whatever were sticking to this plate, they will be now released. So, these magnetic particles are separated and non magnetic particle will be projectile, and if you can have a chute over here and they will be separated out. So, this is how the magnetic separation takes place, and the most widely used this froth flotation. Froth flotation is exactly used for your sulphide ores. That sulphide ore are for copper, for lead, for zinc and many other. There we have got this sulphide ore, which are exactly very easy for separating by froth flotation. Now, there exactly the powdered ore will be giving with a, you are having in a water, and then you will be having an agitator. You can say this is an agitator, that means the fine particles and the water, they will be mixed and this will be agitating. You can see that in the flotation process they are just putting it over there. Sometimes you can send air also, and then you add here stabilizers and collectors. Now, when you are putting as a collector that pine oil or fatty acid, they are used as collectors. Now, what they do? They are exactly enhance the non-weightability of the mineral particles, so that they will not getting it, that is they will be not having the affinity to that water, so that they will be having a tendency to go to the froth. And there are also sometimes some that organic oils like your cresols and aniline, they are added to stabilize the froth, that whatever the foam is created at the top, they should be remaining in foam position, so that this foam do not break, because if the foam break, inside the foam these particles have been lifted and that is there, and that foam or the froth is allowed to pass over here. So, here in this launder you get the concentrate. So, now this what happens from here, they will be this rotating plate, it will be just pushing them over here. So, you know that this froth flotation system is, we are having the main ore crust and powdered ore and gangue material, they are coming as a slurry, and then this is a bubbles are getting formed, and that bubble it just make the buoyancy increases, they go to the top and then they remain as a froth. In that froth, that your valuable mineral particles are there. Now, this they can be, you can take here, there are a lot of advancements can be done, how you sense it there, whether this exactly the proper froth, whatever expected has come or not, whether you have given the adequate quantity of the pine oil or the fatty acids, or then sometimes you use this depressant, that is to separate the sulphide ores, that by adjusting the proportion of oil to the water and then using that sodium cyanide, they can improve the function of this froth flotation process. Now, this in the froth flotation processes, some of the terminology you may be hearing, that the first stage of the froth flotation is called your roughing. Now, in roughing what is done, the material is coming out maximum, that initial froth, and then sometimes the pre-flotation step is followed for being, that is before roughing operations also you can separate out some of this. So, this is done to remove the contamination such as organic carbon etc., if it is coming, that roughing job is there, the processing people will be doing this job. Then that you do the flotation, that sometimes you clean the froth also. During this step the undesired materials can be removed from there, and then the scavenging, that when scavenging is when the froth has come, how you are separating it out. So, that as we said, that is your sometimes different type of collectors and frothers and modifiers are used in the your froth flotation processes. So, those in the metallurgy you can do. The another thing is called your leaching. Leaching is also a separating and concentration process, in which the extractable mineral, they are exactly that made to dissolve into a liquid, and then that liquid is taken out from there, and then you dry it out and you separate these things. So, this is a leaching process. Sometimes you may be hearing this leaching, that is your when you apply in an agricultural field a lot of fertilizers, then that fertilizer also leach out in the water and they do it, but that is why you need to handle them in a different way, that in the field how will you give it. Similarly, if some of the valuable minerals say for example, sometimes even that your there is another things terminology similar to it is there solution mining, which is a different in situ you can dissolve that thing in water, but if the valuable mineral which is there you can put them in a heap and then this crush material it is there and you give it this the liquid, the solvent, that is called your lixiviant. That lixiviant solution is applied over here, so that then they will be dissolving the valuable that mineral, and then those, because there is a impermeable layer is there, and from that impermeable layer that whatever the water will be percolating and down you collect it over there, that is a pregnant solution. That solution it has now brought all the valuable, and then from there you can take it out, and then when your material is taken, then there will be the barren solution, that your solvent is again coming. That solvent can be your as a lixiviant, it can be again pumped out there number of times, the same thing can be going on. So, this is a method of leaching, but that putting that extracting from the liquid media, that leaching has got another type of leaching also, which you might have heard about, that how aluminum is extracted from the bauxite. There exactly you put this alumina from that bauxite, that you are as a iron oxides and titanium oxides, they are separated out from here. Now, what is there, that sodium hydroxide, that is your that alkaline solutions at a high pressure and temperature kept in these ones, and then you have got the high electrode. Exactly, this is now in future, or some of our carbon, that from the coal you extract the carbon, you made the electrode and it is export. India has got a very good business also of exporting these electrodes for aluminum industry from, I think, near MP number of farms are there, they export this electrode, that for doing this electrolytic the separations by the putting this aluminum oxide will be going to the solutions under the action of this electricity pass, that is your in a dielectric it will happen. So, this is also putting the things into the solution. When it has come into the solution, then you take it out, and there it is a concentrate of aluminum will be coming from the bauxite. So, this is the way how you exactly from the ore by leaching you improve the concentrations, that is your in situ leaching, which is done in some of this your in I think it is Kazakhstan, where that uranium mining is done by solution mining. You dissolve the solution and then take out the solution, you do not remove any solid rock or mass or anything, you are just pumping in the water, and water that ore is dissolved, and from there you take it out and get the yellow cake for extracting uranium. So, that type of is a in situ leaching or solution mining is there. And then other thing is that from the ROM, run of mine, you can put it as a dump, and from there you can leach and make a by heap leaching, which will be giving you the pregnant leaching solution, or by crushing with that you do a agglomerations and wet leaching and grinding. After that you can do it as a by flotations, or you can do that leaching by you get a agitated leaching, and from there you do the washings. Similarly, you that under the flotations they can do a leaching the solution and separating it out. Then thermal pretreatment or roasting is also done, there is another process. So, these are the processes for concentration and separation. Now, for that there are different type of concentrator, that is for that your gravity concentration and that your by hydraulic washing, you can have a different trade name, different company, they have made it over there, thinking in which engineered way you can separate the material in a better way, that improve your efficiency and all that. So, when you go to measure the performance and efficiency, that will tell you what type of new solutions, new engineering you can do it. So, in a Nelson concentrator they have done in a very nice way, that you are having a chamber in which these ribs or the blades type of things are there. Now, the feed is coming from centrally, you are pushing the water and this ball is rotated. When it is rotated, you can see that your the light particles will be going up, and this your heavy particles it will be going down, and they will be getting collected. So, this is the way how Nelson concentrator works. Similarly, there is a Falcon concentrator, depending on the company, depending on the persons, their engineering way they have done. here the difference is that the mechanism of it has, that is the difference is basically higher rotation speed than the Nelson sheet. So, they do it is at a very high speed they work, and over there. So, as a result the feed, depending on the feed size, depending on your material properties, you can find out that whether in your case that with the Nelson concentrator will work or the Falcon, but here what is done, the feed is coming over here, and then your this when they are rotating over there they get it mixed, and then your heavier dilution water it comes out over here, and your heavier outlet, heavier material will be coming over here, and the lighter is going like this. So, that means they are two layer wise separated depending on when you are giving a rotation at a speed, and then your material is falling out, that mainly it is a gravity separation. So, the same gravity separation is very simply done by the concentrating table, that is your tabling, sometimes the word is as a tabling, the feed of the material it will be coming over there, then it is used for the coal washing with the coal, and that inside the coal there will be dirt, that is your maybe your sandstone or that your shale, they will be when allowed to move like this, then the particles will be coming, a heavier particle will be falling down, that means that because sandstone and all are heavier, they will be, and then from there the coal will be going at the top and they are separated. So, that at which stage what is separated, these are studied. Then the spiral also, that your whole feed will be going over here, and then when they will be going through a spiral path, then they will be started their the heavier material, the dust particle and all, they will be going to the centrally you can collect them and they will be reading, that is, and then the lighter particle which is there as a, this will be as a rejected over here. That spiral classifier can be used in your just like as a gravity separations. So, these are different type of concentrator. In a spiral concentrator you can see that if you just take a cross section here, it will look like that. You can see here the heavy particle is coming towards the center, that lighter particles are going outside the things, and from there they can be separated. So, ultimately what you have just learned that there are different type of. So, this is a electrostatic separation, your feed hopper, that velocity, and then your vibratory feeder is there, it is making this material to move, they are magnetically getting connected over here, and that non-magnetic particles are going over here, then that you are having a brush by which your all the magnetic particles which are getting connected, they are just separated out. This is the way the your electrostatic separations can be carried out. So, there are, that is a what is a conducting type of mineral and what are the non-conducting type of mineral, based on that electrical separations can be done. There are number of minerals are there, that is who are conductor, like chalcopyrite for your copper, galena for lead, zinc, graphite, your ilmenite, pyrite, stenite, wolframite, that tungsten, these are exactly conductor, that quartz, feldspar, zircon, apatite, garnet, most silicates and carbonates, these are non-conductor. But only thing is there, different way your concentration and separations can be carried out, but you will have to know the basic principle, the properties of the material and the engineering, how those different concentrators are made, and then it is you, that is your, you can take more studies, identify that how the efficiency and the performance of this concentrator will be there. If you are in charge of a processing plant, how can you improve the recovery, or how can you just analyze the tailings, from there what could be there. Now, in a near future there will be business that how to do this waste to wealth, and then the very fine particles will have to be separated out, which there is a challenge. And then say for example, in Japan, they technologically advanced, they are purchasing the iron ore even having 45% of iron, but because they have got an advanced technology they can separate it out, and we are in our, because we have got lot of iron ore, we are not doing in many times 60 to 65%. If it is below 60 to 65% in the ore, we say it is reject. Now of course, by law we are segregating and putting it in a whole mine area, and in near future very soon many of the mines will get closed. There are huge amount of bulk material which are lying in those dumps of the waste rocks, which will have to be handled, and from there the wealth generation will be there. Whether we make it a sand for construction, we extract some aggregates for road building, or the valuable minerals for other metallurgical purposes. So, there comes the business of your bulk material handling. Thank you very much.